If you have any questions, stop me anytime. You know that. So first of all, I have to write a difference quotient for this function. Of course, you cannot write this in as a solution, but the way you should be presented in homework, test, final exam is this: f of x plus h minus f of x divided by h. And because it's quadratic, I would take this aside, f of x plus h. So I will write f of x plus h equals negative 2 x plus h squared plus 4 x plus h minus 3. Then I will continue, first of all, squaring and then distributing negative 2. So I have negative 2 x squared plus 2xh plus h squared plus 4x plus 4h minus 3. And finally, negative 2x squared minus 4xh minus 2h squared plus 4x plus 4h minus 3. Because it's so long, I don't want to drag the whole thing with me several times. So I prefer, just for the quadratic function, I prefer determining this aside. So then, you know my style already. We jump over all this. And I will write, I always run out of room. Watch me run out of room. So negative 2x squared minus 4xh minus 2h squared plus 4x plus 4h minus 3. I reach the negative symbol that has to be distributed to all three terms. So positive 2x squared minus 4x and plus 3. Now I think of what has to happen, and there are two things that have to happen. All terms without h must go away. And if some of the terms with h go away, it's even better. But not in this case. And then I see there are three terms remaining in the problem. I will have to pull out h because they have to have h in common. Why? Why do they have to have h in common? Because I know that the second step has to happen. It's mandatory. So then I have negative 4x, negative 2h, and plus 4. Because h times negative 4x is this, h times negative 2h is this, and h times 4 is 4h. And this is the simplified form, and it's done. Negative 4x minus 2h plus 4. Any questions on any of the steps? This is a very important type of problem you'll see in chapter 1. Why?
Do you need to pull out a 2 to simplify it further?
You can simplify, you can only factor it. There is no more simplification, even if I pull out a 2. It's not incorrect. You could, but there is no need. This is fine. This is perfect. But you could write it like this. Negative 2 with 2x plus h and minus 2. You could. There is no need for this particular exercise, but both of them are perfect. Very good question. Good. Now, anything else that you want to discuss? Anything on this? Okay, now let's go to your questions. Anything that you have for me today? Anything you want to go over?
Is it okay if we can do another problem just like that one? So I can...
You mean like this one?
Yes, ma'am.
Yes, of course. At the end of the class, because I have a plan. I always answer my students' questions, but we already had this one and we had last one with a video and everything. With more than happy, I will, at the end of the class, I will spend with you another, choose another problem and we can go over it.
All right, no problem. Thank you.
Sure. Good. Other questions? Does anyone else need anything? Okay, in that case, let's take a look at R.3. And let me open the book. I was just going to open it when you started coming in. Let me open it so it's open. And we're opening it on page 32. I'll share my screen in a minute. I just want to make sure that the e-text is there, and chapter R is there, chapter opener is there, and I type in 32. Okay, 32. Okay, so this section basically, let me share my screen now. This section refreshes our memory on domain and range for different functions. And I would like to start with graphs. Okay, go up there. Okay, so look at all these graphs, and you can choose any graph you like. And we have 7 questions to answer to find the domain, find the range, and they're asking us for some values to determine. Any preference, or I will pick? So domain and range.
30.
Which one? You said 30?
Yes, ma'am.
Very good. Okay, so let's take a look at 30. And I wanted to see if I can open this. I just wanted to, I have to move it up a little bit. It doesn't matter. Okay, I just wanted to enlarge it. Can I enlarge it, display? No, it doesn't allow me to. Okay, perfect. So this is a function. How do I know it's a function? By the vertical line test, I know it's a function. Any vertical line through the graph crosses the graph in no more than 1 point. So that's why I know this is a function. So we selected problem 30 on page 32. Now, in order to determine the domain refers to values of x. To determine the domain of this graph, I have to go to the leftmost point of the graph. And the leftmost point of the graph is right here at -5. This is 1, 2, 3, 4, 5. And it is a full point. What does it mean to be a full point or not? So here is an open point, as you see. But this one is a full point. In other words, there is a value of the function for x equals -5. Then I see the graph is smooth, continuous. We will talk about continuous functions in the next chapter. So, and now I look at the rightmost point. At the rightmost point, the x value is 4. So I will write the domain in the following way. So domain is from -5 to 4. I'm using brackets. I'm not using parentheses. If I use parentheses, it means that there is an open point, as we had in our piecewise defined functions when we graphed them. But this one means that it's everything between -5 and 4, full point. So this is domain, values of x, in other words. If you have questions, please stop me. Now, when I need to determine the range of this function, I see that the function starts the lowest possible point of this function in the y values. The lowest one is, can anyone tell us what it is?
-3.
Perfect. And it goes smoothly. All points exist till what point?
4.
Yes. So till what point? On the y-axis. We're talking about y-axis. We're determining the...
2, I'm sorry.
That's okay. So indeed, both of them, I have to use brackets. Why do I have to use brackets? Because the points exist. They are full points, in other words. Okay. Now, they are asking us to determine a few other things. Here they are. F of 1. I need to explain what f of 1 means. When we're asked to find f of 1, so bear with me, we're not going to read from my graph, but I just need to have a graph here. So let's say it's this graph. It's not exactly, but doesn't matter. So what am I asked to determine? Well, I am given that x equals 1. Remember what we discussed about x equals 1. When we look at the equation x equals 1, you can say, okay, this is a value. Yes, but also a vertical line. So it means that I have to draw, wherever x is 1, I have to draw, or imagine I draw, I don't really have to draw it on the graph, the line x equals 1, I see it crosses the graph of the function in a particular point, and I have to read the y value. That's what I'm asked to determine here. Find the y value when x is 1. So let's see which point are we going to read from. So can anyone give it a shot? It's okay if you're wrong. Just answer the question, please. What do you think?
2.
Excellent. Thank you so much. Thank you. Indeed, the answer is 2, because we read from the point. So when x equals 1, we read from this point, and y is 2. So that's why the point we read from is this one, 1, 2. When x is 1, y is 2. Any questions on this? Okay. Now, they are also asking us to determine x when f of x is 2. This is a different story. So when we're told f of x equals 2, we're literally told y is 2. Find x. But y equals 2, you can say it's just y equals 2. True, but it's also a horizontal line. Y equals 2 is a horizontal line. So how do I graph it? Or imagine I graph it. Okay. So this is my y equals 2. It happens that it crosses at that point, and I read the x value. So I already have the answer because I already solved the same thing a minute ago. So again, I'm reading from the point 1, 2, which means f of 1 equals 2. So I'm assuming we get the same thing. We'll see. So yes, in this particular case, sorry, because it's continuous. Sorry about that. So my graph is, I was thinking, I graphed it and I wasn't looking. So when y equals 2, we have a bunch of values. Not just what I wrote, 1, 2. Yes, that's correct, but that's not enough. I have, when y equals 2, x is 1, x is 1.1, x is 1.2, x is 1.3, x is 2, x is 2.1, x is x is 3, x is 3.1, x is till 4. All this interval, all these x values from 1 to 4, all of them have y equals 2. So this is one example, but this is not enough. So indeed, when f of x is 2, x is in the interval 1, 4, all those points, because it's a horizontal line. So y equals 2 means x equals 1, everything till including 4. That was just one example, one point, but everything here. Good. Any more questions, or do you think we need to look at other graphs, or can I move on to other types of functions and functions that are not graphed for us? Okay, so let's look at different types of graphs or functions. So here's one comment. Polynomial functions exponent, oh, sorry, I forgot to stop sharing. So polynomial functions, exponential functions, we're going to talk about them in chapter 3. Exponential functions, polynomial functions, they have domain all real numbers. I like to call these functions friendly. I don't have to worry about them. They exist for anything. What do I mean by polynomial functions? Linear, quadratic, cubic, any of those. All polynomials. They have domain all real numbers. Friendly functions. The same thing with exponential. Well, but we have others like rational functions, logarithmic functions, radical functions. These are not friendly. They may be, depending on the function itself. Because a rational function can be, for example, x squared plus 2. There is no problem with that. A logarithmic function can have, let's say, also log of x squared plus 4. There is no problem there. But these, in general, we have to be very careful about. They don't necessarily have domain all real numbers.